Hello world. Thank you very much for joining in. My name is Stefan, the Flashover, and today we are going to build a source generator for for attributes for the feature nullable reference types, which was added in C# 8. We're gonna explore at the connection between both the C# compiler but also the BCL, which offers additional attributes, and how this goes together, and what we can do to support nullable reference types for lower .NET target frameworks. But we will get along this in just a bit. So first, as a bit of an introduction, I would like to show something very similar. I would like to show what the connection between the isExternalInit class, which has been added in .NET 5, with the init-only setters features, which has been added in C# 9. And so we have the C# 9 feature, which requires a type from the .NET 5 ECL. But what if we are not targeting .NET 5? What if we are targeting, for example, .NET Standard 2.0, for example, where this type does not exist? Can we then actually use C# 9 init-only setters? Yes, we can. We can either provide this type manually because the compiler just needs this type available. It doesn't really matter where it is coming from, either if it's coming from the BCL already or if we provide it manually for lower target frameworks. It could also come from another NuGet package. This is already existing solution which adds C# files via MS Build. Or those types could, or this type could also be source generated via Roslyn generator. And so this is an existing solution, and then we're gonna have a look at how we could add those nullable reference types attributes. Either also provide them manually, have a look at an already existing solution, and then we're gonna build these via incremental source generators with Roslyn. And at the end, as always, gonna have a look at the code coverage report and the mutation testing report. So what's this isExternalInit class and the init-only setters feature? If you have a look at this type, it's the isExternalInit class. It has no members. It's just a type which is there and is available since .NET 5. And if we have a look at the init-only setters feature, this has been added in C# 9, where we can, instead of a set accessor, can write an init accessor, which then only allows properties to be set with an either through a constructor or via an object initializer, which is here. So here we have an object initializer where we can set these. But after the object has been initialized, we cannot set it later on. Like this does not work because the temperature in Celsius here is an init-only setter and not a regular setter, so it can only be set in object initialization. I will now have a look at the trusty SharpLab. And let's see. Oh no, to make a typo. There it is. What is going on under the hoods? So let's define a class, and this class now is a property, public int number. And we're gonna make this get and set. So this is usual pre C# 9, where then the compiler generates both the get and the set accessor with the backing field behind. And if we change this to an init, it's basically changed to an init. But the compiler requires a type to exist. So if we jump now to writer, look at this sample here. Let me, before we start, comment out this generator, because this generator would generate what is necessary. And if we have a look at this example, we have here a record type. What a record type basically is something similar to that. Actually, let's have a look in SharpLab, and we see exactly what's going on. Let's paste this record type in here. Let's use the main branch. And we see that this record class called record is actually translated to, or compiled to just a regular class. So the record is just a C# keyword. It doesn't really exist at runtime, but it generates a whole lot of code. So first, our type is now equatable. The member that, or the argument that we put into the argument list of the record becomes a property with an init only setter again. And we also get a toString overload. We get the equality and inequality operators, a hash code, the equals method overloads, and so on. There is also a clone method so that the with syntax works. And also deconstruction works out of the box with a record type. But again, we have here the init only setter. So this again requires the type to exist. And we have the type here. It's the is external init type. So this compiles. We can run that. Examples 1. What we do is we create a new instance of this record. We set it to 1. Then we create a copy of it with this with keyword, where we can again set all the settable or init only properties. So this is now a copy where we set the property now to 2. And if we print this to the console, then we see down here it's the instance where the property is set to 2. And this works because we are using the latest language version, in that case C#10, and we are targeting .NET 6.0. I should zoom in a little, I guess. So this is external init class is available since .NET 5. So if we go to .NET 5 and try to run this, it compiles and it still works. Actually, let's change this to 3. We see that something changed. And we now have a 3 here. Excellent. But can we go lower? Let's target .NET Core App 3.1, for example, where this is external init keyword class does not exist yet. And if we run that, now we get a compiler error, which says the predefined type system runtime compiler service is external init, is not defined or imported. So it doesn't exist. So in .NET Core App 3.1, where the default language is C#8, this is external init class and also the entire init only setters feature did not exist yet. So although we're using the latest language version, let's make sure of that. We need at least C#9, but let's go for C#10. Still doesn't work because this type doesn't exist. We have here the error, this type doesn't exist. And we get the error here that this cannot be created because a record, those members in the attribute list become init only setter properties, and this requires this external type to exist. So we could actually provide this type ourselves. It doesn't matter where it comes from, it just needs to be there. We could create a new class. oops, let's call it is external init and put it into the correct namespace, which is system runtime compiler services. So let's define the namespace up here. And what does it complain? Okay, because it doesn't correspond to the file location, can ignore that warning here. And it's just a static type with no members at all. And now this type is there. And if I hit the run button now, it compiles and it works. Actually, let's change this to a 4 that we see that something has changed. And there it is. And now it works again because we have basically manually defined this required type that the compiler needs. If we're managing multiple projects, for example, well, let's start. A common scenario is perhaps if we want to do multi-targeting and have something like a .NET and want to multi-target with, for example, Net Standard 2.0 or 2.1, where this type doesn't exist either. And if we have multiple libraries where we want to use is external init only setters, then we could basically paste in this type in all the libraries where we need. Perhaps we should, in this case, define it internally so that consuming libraries don't, or consuming applications don't get that. Because if we would define this in a Net Standard 2.0 library, and then this may be consumed by a .NET 5 or .NET 6 application, which already has the isExternal init keyword from the BCL, then this may this lead to trouble because it's defined twice. I don't think during compilation, but if you want to via reflection use this type, or not via reflection, but actually, yeah, try to consume this type, then there would be a ambiguity between which type because it's in the same namespace. Maybe it actually would cause compiler errors. I'm not entirely sure, but this should be avoided. So let's do it internally so that consumers of this library don't see that because they may not need it because they are already at a higher target framework. Okay. Where was I? Yes, we defined this internally. Oh, yes, a different solution could be, so if we don't want to copy this now to all of our libraries to get it work, there is a NuGet package called isExternalInit. Let's add that. isExternalInit, there it is, version 1.0.2. Let's add it. Let's change the 4 to a 5. We already see that this is now compiling again. So if I jump to that source, I'm hitting F12, then we see this type is there, but it comes from, yeah, it comes now from the NuGet package. You see that's the license. It has been developed by Manuel Römer. And we can actually have a look at the package itself. There's a link to it. So here's the package. Let's have a look at how this package looks like. So this doesn't contain the isExternal init type as a DLL, but as a C# file, which is then basically added during compilation. So if I'm targeting Net Standard 2.0, then this would be the file that is included, exactly the file that we are looking at, which now defines again internally the isExternal init. So it now becomes part of our compilation, but we don't have to add it manually. And it's only added if it's required. So if we would target .NET 5, oops, is that the file? It's actually there, but I think then it doesn't get included then. because it's already there in .NET 5. So it's only including it if it's actually really needed. And with that package, now we can run it, set the property to 5, and it works again. So again, it doesn't really matter where this isExternal init type is coming from. It just needs to be there for the compiler to be consumed. And another solution could be, we go to the CS proj, let's remove what we see, this isExternal init. It's also private assets all. That means that all the dependencies, they don't transitively flow to any consumer of this. If this would be a library and somebody would be consuming that, the isExternal init dependency wouldn't transitively flow to these as another dependency. So if I remove it and would try to compile, let me change this to a 6 now. Try to compile again, we already get an error. The type is not there. This could also be source generated. So this is a package that I have built previously. The first incremental source generator actually built. And now if I run it again, it works. We now have property set to 6. So this type is there again. If I now go to the definition, we see that this is now in an .g.cs file, which is generated by an incremental generator. Let's have a look at that actually. That's here. So this is the generator which generates the isExternal init class only if it's required. So we first create ourselves our syntax provider. Let's have a look at the syntactic check. We basically have two use cases. Either if we use the isExternal init keyword directly. So let me jump back to the example. If we would have a class, my class, which has a property, let's make it a string text. And if we explicitly say, okay, if we use the init keyword explicitly, now we require the type. Or if we use it implicitly through a record with the argument list here, because that now generates, or more precisely to say, synthesizes a class which has a property where the setter is init only. And for these two use cases, we basically we have a look at every syntax node and we check if this syntax node is an accessor declaration. So this could be either get accessor, a set accessor, or the init accessor. And we see if the keyword is actually the init keyword. It could be also the set keyword or the get keyword. And if we have the init keyword, then we say true, then we require the type. There is external init type. Or if we have a record declaration, only if the parameter list of this record type has at least one entry there. Because if it doesn't have any entry, if I would remove this, then the compiler doesn't synthesize any property which has the init only setter. And additionally, we need to now take care of what kind of record it is. With C#9, there was only a regular record that we would define. Let's jump back to SharpLab. If I remove the class here, if I just say record, this is now a C#9 style record, which creates or synthesizes a class where the attribute in this, or not attribute, but this argument list is turned to a property with an init only setter. Now with C#10, we can also write class, and this is the very same. It's just meant for explicitly for explicitness, so that we know, okay, this is a class. Because with C#10, we could also write struct. But if we do a record struct and let, sealed is not, sealed is not allowed for a struct because it cannot be inherited. If we do a record struct, this is now, and now a struct is synthesized with the very same behavior. Okay, that's not the best because it's a value type, but with a very similar methods synthesized. So it is also I-quotable. We do have a property for this argument here synthesized. We have a two-string overload. Equality is overloaded, hash code is overloaded, and so on and so forth. And deconstruction works. So that's very similar, but the difference is that it's a class, that is a struct, and also that the property is a setter. So this is not an init only setter. However, we could turn this into a read-only record struct. Okay, I lost the connection. It help if I refresh this page. I hope it does. No, it doesn't seem to work. But if we turn this into a read-only record struct, now the property that is synthesized here again has the init-only setter. So if it's not read-only, it is a set. If it is read-only, then it's an init. So we need to find out what kind of struct it is. Either if it is a regular, or not a regular, but a C#9 class record, or if it is a read-only record, but not for a regular record, because a regular record has a set accessor and doesn't require the init-only class to be there. So this is why we need to then have a look at the record declaration. A record declaration, since C#10 has a class or a struct keyword, and if that is a struct keyword, then we need to have a look at if the read-only modifier is also set on this property. And then we require, so this would mean this is now a read-only struct, a read-only record struct. When it has a parameter, then we require the init-only keyword. In any other cases, it's either the class or it's a struct keyword, or it's the it doesn't have any keyword at all because it's maybe C#9 style of code. And in that case, we also require this external init keyword. But if it's a non-read-only record struct, then we don't need it. And yeah, so this is our syntactical check. For the semantic check, we are not doing a lot. We basically just return the node. Then we also need the compilation. So we're going to combine the syntax that we have collected with a compilation provider. And we also would like to have the parse options to find out which language version it is. If we now go to the execute phase of the generator, we first have a look if are there any nodes. Actually, did we find any node which requires or is init only keyword? Or so if we don't have any, then we can just return because we don't need to generate the is external init class because it's not required. But if it is required, we also should have a look if it is defined already. So we have a look at the compilation, is what we need the compilation for, and see, does this type already exist? It doesn't matter if it's coming from the BCL or the user has defined it themselves already, or it's coming from another package, for example, the isExternal init package. But if it's not there, so if it's null, or if it's not null, then we have it already. Then we don't need to generate it ourselves. But if we don't, we continue. With a look, we get the C# language version and then actually generate the code. And here's the code where we then really create now or generate this type. We always put on top the auto-generated um, comment so that other analyzers by default don't try to analyze that code because that's generated and the user doesn't really have a direct impact on how this is generated. And if we do have, I have here a check, if we have file scope namespaces, which basically means, oops, which basically means if this is C#10, then we can do a file scope namespace. Otherwise, we create a block scope namespace, define our type, and at the end, then put this into a file called isExternalInit.g.cs. So this type is now only generated when we actually need it. So if I remove those types, get rid of this code, now we get a compiler error and say, okay, this doesn't exist. So this here doesn't work because this doesn't exist here. It's still there, but this may now be a caching issue of tooling. If we would .NET build this, we now get this error. So this type is now, the isExternal init type is not generated because we don't have any init only setter defined or any record which requires it. And yeah, so this is the thing between a type and the C# language feature. And now I would like to build something very similar for nullable reference types. Let's jump to the, so with nullable reference types, they have a bunch of attributes where they are quite a collection of attributes where we can further define the meaning of nullability. And perhaps a bit of a refresher. There's a significant difference between a nullable reference type and a nullable value type. I hope that Droplab is back up. Yes, it seems so. Let's enable nullable enable. Oops. And let's do a class which perhaps has a constructor which takes a string. Well, let's start with, yeah, which takes a string, text. So here we now say, since we have nullable enabled, it's a nullable reference type feature, we basically say, okay, this should be non-nullable. So if we have some code, let's do a class called caller, public void method, and we would like now to instantiate this new class, equals new class, and we want to pass in null. We should get here a compiler warning because we try to pass in null to something which is defined as non-nullable. Yeah, there it is. We cannot convert a null literal to a non-nullable reference type. If I would like this warning to go away, then I can define this as nullable. Now the warning disappears because we now specified, okay, that this may be null, which now means if I would try to dereference it, if I say text.length, I get a warning here now because I'm trying to dereference a possible null reference. So we're saying this could be null. It doesn't have to be null, but it could be null. Not a compiler warns me, hey, I'm trying to dereference something which may be null, which would lead to a null reference exception. So I should guard this with a null check. Let's say if text is not null. And now again, this warning goes away because we told the compiler, okay, it may be null, but you do a null check here. So in this block, text is not null. So it's now safe to dereference it. But this nullable reference type feature is only at compile time. At runtime, there is no difference between a nullable string or a non-nullable string, because actually what's happening behind the scenes is that we get attributes synthesized on the members where we define nullable reference types or non-nullable reference types when we are in a scope, when we have the nullable feature enabled. To be more precise, the nullable annotations. So we could, for example, enable only the nullable. Also, it's enable annotations. Yes. So now only the annotations are enabled. So we do have, we do get this attribute here synthesized, but we do not have any warnings. So if I would now reverse this null check, say if text is null, now the compiler knows, okay, in this block, text is null. So this should now emit a warning, but it won't because we only enabled annotations. We haven't enabled the warnings. We could, the other way around, also just enable the warnings. But now we would get a warning here. Sharplab is still working. There it is. We now get the warning here because annotations are unenabled, so we cannot really annotate it. And with just nullable enable, we enable both the warnings and the annotations. And yeah, now we get the warning again. So we need to do is not null. And what's happening, yeah, is that basically the compiler adds attributes to it to tell during the compilation whether something may be null and it should be null checked before dereferencing, or it may not be null and we can safely dereference it. But at runtime, we see this is only attributes. At runtime, it's still the very same string. And that's the significant difference with nullable value types. So if I would pass in here a number instead, let's pass in 0 here. Say if number doesn't matter, let's just say number here. Now this is a regular non-nullable value type. It always has a value because it's a struct. Structs always have a value. But if I would make this int question mark, now this actually at runtime is something totally different. It's no longer an integer, it's a nullable of integer. And nullable of t, that's again a struct, which now basically wraps this value, indicating that it may be null. So in order to get to that value now, I must say dot value. But here now we get a warning because we could try to access a value which isn't set yet because I could pass in here null. Now this is factually not 100% true because nullable of t that we see here, that's again a struct, so it must have a value. But the wrapped value that we have here may not be initialized because we say here null. And in that case, we would not get a null reference exception, but we would get an invalid operation exception, I believe. Let's actually have a look. That's sites of .NET. Let's go to source.net. Nullable of t. There it is. And let me zoom in. We see here, this is basically, it's another struct, which is constrained where the t is any struct. We have the has value boolean and the value getter, where if we don't have a value, then we throw an invalid operation exception. But if we do have a value, we just return it. So it's not a null. There is no null reference exception because, again, the nullable of t is again a struct which cannot be null. It always has a value. But if we don't initialize it correctly, if we don't initialize it and pass in null, which now basically passes in the default of it, where we do not call this constructor, where the has value now is false and the value is default. In our case, it would be 0 because that's the default of an integer. But we would get the invalid operation exception, where again we could tell the compiler to do basically it's not a null check but a has check. So we can say, hey, do we have a number? Has value. I think we could also use C#. Is that 9 or 8? For it, we could say number is not null, which basically now translates into number as value. So this is another C# feature, how to deal with nullable value types. And that's the significant difference. So a nullable value type is something totally different to a non-nullable value type at runtime. But a nullable reference type is basically the same as a non-nullable reference type, but just with annotations on top of it. Okay. Well, yes. And now there are more attributes. There is a bunch of additional attributes we can use to further identify the intent of nullability that we would like to communicate. I have here another solution where this is a previous talk of mine. Talked about nullable reference types. And here I have a bunch of examples on how to use those additional attributes. And we see those new attributes, they have been added. They are available in .NET Standard 2.1 and .NET Core 3.0. For example, the allow null attribute. We can put the allow null attribute here, which basically says, okay, this is a non-nullable string. See it up here. No, we don't see it here, but we see it if I go to the CS proj. In the CS proj, we have here nullable enable. So both warnings and annotations are enabled in the entire project. And we have here a non-nullable string. So if we would set assign null to it, it should produce a warning. But we say, okay, allow null, which basically tells the compiler when we try to get it, it's always non-nullable, but we do allow to set null because we ensure, okay, if it actually is null, then we do string empty, for example. So we ensure, we tell the compiler, okay, there is code in place that ensures that this text is never null. So setting it is fine, but also, so we can set null to it, but dereferencing it is also safe because it's a non-nullable string. If we would remove this attribute, then we would get a warning at the usage of here the string, and we would get here the warning if we try to assign null to it. We cannot convert a null literal to non-nullable reference type because it's a string, it's not a string question mark. So we cannot assign, or we shouldn't assign null to it. But again, it's just a warning. Unless we have warnings as errors, then it would be an error. Yeah, and if I add this attribute, now the compiler knows, okay, assigning null is fine, but it's still very safe to dereference. Although we assign null here, it's super safe to dereference it because it told the compiler it's cool. But we could lie to the compiler. If I would remove this thing, or I would just now basically assign null here, this actually gives me, ooh, this is new. Is this a wider feature or is this a .NET feature? What if I try to build this? Would I get a warning? I do. Ah, yes, of course I do. Of course I do, because I'm trying to assign null to a non-nullable string. But if I would get rid of it entirely, oh, I still get the warning. That's cool. So, okay, I had to attribute my bad. Yeah, I had the attribute on top. So if I now would remove the attribute, um, now we have the warning here again at the usage, because so no, I wanted to show how we could lie to the compiler. Actually, we can't lie to the compiler. That's cool. That, I guess that's new. Okay, so we have here full safety. If we have warnings and errors, we can't do anything wrong. Let's revert that. Okay, cool. And there is many more attributes. Perhaps let's show one more. One which has been added in .NET 5. So this does not exist in .NET, in any .NET standard. Only available since .NET 5 and up. Which is the member not null attribute. So a common issue is if we have here a non-nullable string, but we do not set it, we do not initialize it in the constructor. So this is why we get the warning that this non-nullable field underscore value here is uninitialized. So it could be null, although we say, oh, it's non-nullable. If we add a string question mark here, the warning goes away. But if we have it not annotated as non-nullable reference type, non-nullable string, then we do get the warning. However, we do initialize it, because in the constructor, I do call the initialize method, and we then set it in the initialize method. So everything is fine. We pass in a non-nullable string, and then we assign down here the non-nullable string. But the compiler is only doing static analysis. It doesn't do any dynamic analysis. This would be way too expensive. So in this case, we need to help the compiler to tell him we had a member not null attribute that, hey, if this method is invoked, then these members are not null. And now the warning goes away, because the compiler knows initialize. If this is called, then value is not null and the contract is fulfilled, because this non-null string has been initialized. It's non-null. It's safe to dereference. But here, this is the place where we could lie to the compiler. If we, for example, remove this code here. Oh, this is good. Okay, this is new. Oh no, this is now actually a different warning. So we get the value is never assigned warning, but we don't get the nullable warnings. Yeah, so here we could say, but here we get and now we get a warning here, because we say, actually we can't lie to the compiler. This is pretty smart, because we told, get the warning again. We told here that this member should not be null, so it needs to be initialized. And now we get a warning here that the value must be not null before exiting this method. And we don't set it, so it may be null. And if we have warnings and as errors, this wouldn't compile. So forget what I said, we could lie to the compiler. In this case, this is actually good. I wasn't sure if I missed this previously or if this is now new with .NET 6, not sure. But that's pretty cool. And if we bring it back, now everything is green again. If we have warnings as errors, we wouldn't get any error, and everything would compile just fine. And there's a bunch of more of these attributes, and I would like to add now these attributes if not existing via a source generator. But it's only a gimmick, because let's actually take this example. Let's take this example actually. Copy paste it to the generator project. Let's do this as an analyzer test. So let's add an nullable attributes tests class to it. Is this a type already? Yes, it is. We not need this. This suffices. Yes, and we see this allow null. It doesn't exist because we are. Oh no, it should exist in .NET 6, but it doesn't exist in .NET Framework 4.7. So we should be able to actually include the using. Let me put it manually. It's in the system diagnostics code analysis namespace. So if I put this using on top here, now this does compile or should compile for .NET 6, but doesn't compile for .NET or anything not compatible with .NET Core 3.0 because let's actually jump to this attribute. It's the allow null attribute. If we look at the documentation, allow null attribute, there it is. This has been added in Core 3.0 and also in Standard 2.1, but it's not available in any lower target framework. So if we would .NET build this for, is it framework? Is it -f .NET 6.0? This should work just fine. It does. But if we do build it for .NET 4.7.2, so that's .NET Framework 4.7.2, where this type does not exist, we get an error saying that, yeah, allow null attribute, it's not there. So I would like to have a generator which adds it if it isn't there, but doesn't add it again if it is already there. So, okay, so we have here a bit of an integration test. Let's for now comment this out because it would break the solution build. Let's go back to that. And of course, we also would like to have a unit test. So let's start with an nullable attributes generator tests here. I will begin with a generator which creates all of the attributes. Perhaps later on I'll split it up. Not sure yet. I will go peek at a previous test where we have a bit of a setup here. Let's copy those two methods. Yes, we're gonna need the reference assemblies, the language version. With the language version? Yeah, why not? And okay, so let's start our first test. We have a fact, which is, I know this is gonna be a sync task returning. Let's start. If the attribute doesn't exist, then we want to add it. So this would be the not null attribute add if not existing, or add if not defined. And what would we expect? First, we need some input code. Let's actually grab some from the official documentation. So we have here, we see this, those are preconditions. Let's grab this example. Let's do some, it's the user code. And the user code consists of, let me have tabs here. Okay, this should be in a class. Public class. Indentis. Okay, we have here generate random screen name. Let's just do a string.empty here instead. We are going to need the using. What was it again? System diagnostics code analysis. And we're gonna need system. Using system. Okay, this should compile fine. And the generated code would be this attribute. So we could assert that the string generated code should now include this attribute. I will again go peeking at the actual implementation in the BCL. Let's jump to the not allow null attribute, which is in the core lib. Let's go to the actual GitHub source. There it is. Okay, so they actually have one class which contains all the nullable attributes. Perhaps I'll do that similarly, not sure yet. And there it is. So it's basically just a attribute super empty with this attribute usage. So let's assert that we are in this namespace having an internal sealed class, this attribute. This is in the system namespace. So let's say global : system dot attribute. And we require these attribute usages. Let's put them here as well. Are these in system? I believe so. Global system dot system dot attribute targets, system dot attribute targets, system dot attribute targets. Yes, this should be good, I hope. And now we need to assert something. So let's call the verify. We would like to verify that if we pass in the user code, then we expect this generated code to exist in the isExternal init file. No, that's wrong. We assume it in the nullable attributes. Actually, I would like to call it, how is it called in the BCL? Nullable attributes.cs. So I'll be calling nullable attributes.g.cs. So this is the expected file name with the expected string. And we expect it to be not in the isExternal init generator, but in the nullable attributes generator. Now this type doesn't exist yet, so we need to go ahead and build that one. We add to the generator project a new nullable attributes generator. I like to make them internal. They will be deriving from the I incremental generator. Let's implement this type. And we will need the generator attribute where we can say the language name, language names dot is C#. Okay, this should be first fitting test. Okay, we want to pass which reference assemblies do we want to pass? The ones from, let's say, net standard 2.0. Because net standard 2.0 doesn't have this type yet. It exists in net standard 2.1 and up, or compatible with .NET standard 2.1. And yes, let's run this test. This should fail. It'd be weird if it would pass. It fails because generated sources, we expected 2 sources, but there was only 1. So nothing was generated. So we need to generate something. Let's actually start, as most of the times, with a syntax provider. Provider. So we go from the context. Context has a syntax provider, and we create a new syntax provider. The syntax provider has two callbacks: the syntactic check and the semantic check. Let's have a look at the definition. We have a func where we get in the syntax nodes, which is similar to the Roslyn 3.8 and Roslyn 3.9 syntax providers. And we get another callback, the transform callback. We're not really gonna need this because when do we need to create this attribute? Actually, do we really need a syntax provider? Not really, because we want to add this attribute if it doesn't exist. Perhaps we want to add this attribute if it doesn't exist and we have Nullable enabled. So let's also have a test. Let's define that we have Nullable enable. Perhaps at least the annotations. So let's do Nullable enable annotations. And let's define a second test. Public void no nullable context should not generate attributes. So if we have a user code, string user code, actually, it's just, we have, let's do a check if we have Nullable enable the warnings, for example. So there is no annotations. In that case, let's not generate this attribute. So, I'm not sure if this actually, how can we test this? Because we shouldn't check this on a C# level, on a C# file level, but on a compilation level. Not sure how we can control that. But perhaps we need to rephrase that test. Class. We actually, if we would do now here, text, string, text property, get set. This should, or let's do it get only. This should actually create a warning because we defined here a non-nullable string, but we never set it. So this should actually fire a warning. How can we have a look at how this looks like? Let's come back to that later. Oops. To do check if in nullable annotation context on a compilation level, not source file level. Because we can either via this preprocessor directive, we can set nullable contexts on within a source. We can enable it, disable it on a location basis within the source file, or we set it on a CS proj level. In that case, for example, we had a nullable enable. So this will enable it for every file within this compilation, for the entire compilation. But we could overwrite it where the preprocessor directives more locally to the location. But I would like to focus on this. Does this make sense? Now let's see where this goes. Okay. Yes. So we're actually not gonna need a syntax provider for now. Perhaps you're gonna need it later. Let's see what the tests say. Because at first, actually, the minimal thing is that we just created. We could do a post initialization actually, because now we would create it unconditionally to the current test. But let's already use the regular register source output. This creates an incremental value provider and the action callback. So we do need a value provider. Let's use the compilation provider. We definitely gonna need that, most likely. And we have an execute method. Okay, there it is. Let's make this static. We have here a source production context, and this is our source. And let's use the context to add the source file. So we are going to create the attributes, nullable attributes. Oops. So let's once more go to the source code. Let's grab this. Let's grab this entire thing. Oops. Did I do wrong? We need an int verbatim string. Okay, we are to need it like this. I think we defined a file scope namespace. So let's okay. Again, this needs to be in the global system namespace. Let's add it to where it's needed. Okay, and out of this attribute. Okay. And when we add a source, we first say the hint name, which is the per default the generated source generated types are not created as files to disk. But there is an option you can set in MS Build to actually also put them out to disk, for example, in the obj folder, intermediate output path, and then it would be using that name. Also, tooling would use this name to display it, what we saw earlier, and we would like to call it nullable attributes.g.cs. Always indicate with the G that it's generated. We always want to have the auto-generated header on top. I always forget how this works actually. So this is where I go to the sharp nullable reference types documentation and grab it from here. There it is. Auto-generated on top, and let's also enable nullable reference types here. Okay, and now let's add this file, nullable attributes. I have a warning here. It says inconsistent body style use expression. Oh yeah, okay. We can ignore that for now. That is like simple, but could make the first test pass. Let's have a look. I guess the string doesn't match yet, but in general, yes. We see here some diff. The plus indicates that this was not expected, but is actually there. If there was a minus, it's the other way around. So we need to add these. This and Perhaps let's also grab that from the documentation just to be sure. Nullable enable. Okay. Let's run the test again. Was expected to put UTF-8, but we found UTF-8. Ah, yes, okay. I believe I should add it via the, I usually use no bomb. Yes, UTF-8 without bomb, which means add source has another overload. So there's two overloads. One takes, both take the hint name as a string, and one takes a source and one takes a source text. So we're going to use the source text overload. Where we're going to say source text.create, I believe. We're missing a using. It's not source cut.create, it's source from. And what does, oops, what does this take? Takes a string and encoding. Yes, the encoding is what we need. So we pass in the source text and also the encoding. The default UTF-8 uses BOM. I think I have somewhere already an type for that. Yes, encodings.utf8 no BOM. Encodings.utf8 no BOM. Okay, this should fix this issue. I believe my style because I use source text here already explicitly and say here wow var. It's clear that it's source text and the test passes. Cool, but now we unconditionally generate this attribute. We do not want to generate it if, let's add another await here. Should we have a separate test? Guess we should have a separate test. For simplicity, I did just here. What if we're using net core 3.0? Because this is where this attribute was introduced. And for that, we don't want to generate any code because it's already existing. Which now should make this test fail again. Because, yes, we expected only one source, so the user source, but we got two, the user source and the generated source. So we need now we need to check whether we have this type already before we generate it. And okay, where would be the best place to do this? Is it in the execute method? Perhaps we could add a filter for that. Is the syntax provider a good place for that? No, we have the semantic model, but we do need the. Does the semantic model have compilation? It does. Okay, so we could do it via a syntax provider, but I would like to try something different. I would like to try via the compilation. It's an incremental value provider. So no, this does not work. Node. We need to do this in the execute. I believe we do. Unless. Let's do it in the execute for now. Perhaps we find a nicer way later on. So we do have the compilation, and let's say if as double attributes. Oops. As nullable attributes. Let's do it inline. We can refactor it later. The source.compilation. Oh no, we have the source is the compilation. We can get a type name by metadata. Get metadata reference, get type by metadata name. Yeah. And we now pass in the full name of this type, which is system.diagnostics.codeanalysis.allow null attribute. And if this exists, which means if this is not null, then we have it already. Then we can return and don't need to generate it. But if it is null, which means it's not found, then we need to generate it. Now this could render the test green. Ooh. It does. So, sorry, briefly check the messages. If there is something wrong with the stream, yeah. Yes, so this test is green, so we only generate it if it doesn't exist already. And it doesn't matter if the user has defined it or it's coming from somewhere else. For example, from the MS Build package that we used earlier, the Nullable package from Manuel Römer. Okay. I'm wondering if this is a smart idea to only generate it if we are in a nullable context. Well, it may be the CS proj may have nullable disabled, but each source file may have it enabled. So we can't really tell on a compilation level if it is used. But we could tell if it's not set on a compilation level, but in any source file. So we have either the compilation needs to set it, or it needs to be set in any source file. So we need to have either nullable enable or nullable enable annotations in any source file, and that would indicate that we may want to need it. Yeah, actually. And if we don't have anything of that, then we don't need it. So we do need a syntax provider. Okay, but we'll do that later. First, we need a test, of course. So how can we set it on a compilation level? Let's go down the... So, no, let's first have this test. Let's say here that I say nullable enable warnings, async task. And we don't want to, we just have the user code, not generated code. We are netcore app 3.0. No, we want to be net standard 2.0 because this is where it doesn't exist. And it shouldn't generate because we only have nullable warnings enabled, but not the annotations. My unit tests, here they are. And which one fails? This one fails because, okay, we do generate it. but we shouldn't. Okay, now we need to filter that we don't generate it. We can have a look at the compilation. I think the compilation tells us something about that. Source dot. Is there some nullable context options? Nullable context options. There we are. Gets the default nullable context state in this compilation. And this is, I think, the one which is set via the csproj. This context does not apply to files that are marked as generated. Nullable is off by default. Oh, okay. And let's have a look at this one. Nullable context options. I believe this has several, it's an enum with several members where we say, yeah, if it's a 0, then it's disabled. If you have a 1, then only the warnings are enabled. If you have a 2, only the annotations are enabled. If you have a 3, then both warnings and annotations are enabled. Which would be, if I go to this sproj, respectively, example. So nullable enable enables both, but we could say annotations, or we could say warnings to only have one of them, or we could disable it entirely. Oops, not too much reverting. Okay, and if this is if this is a flag. Is this a flag? Could be a flag. Maybe a flag. I believe it is a flag. Then we can say if the flag nullable annotations is set, then we generate it. It's a flex, yes. So we can say dot has flag nullable context options dot annotations, and if we do not have that, let's return as well. But now I believe the test setup that we have is not sufficient yet. Because now, okay, this test turns green, but now the other one fails, which actually expects them generate. Yeah. Because the setup is wrong, because we don't set it up in the compilation that we create in the back. I'm jumping into this, and we need to set now. We need to set this. This can be shortened. Cool. So those are the verifier types, which basically create the compilation and the pass options that are set up for the test. And we need to, here, we create compilation options, and in these, we would need to set these nullable options. So additionally, let's say compilation options dot, is there some with nullable, with options or something? Oh no, those are the compilation options. I need those are compilation options. Let's see what the compilation options have. Do they have some nullable? Nullable context options. There they are. And they are protected set. Is there a with nullable options? No, there isn't. How can we set these? Because we can't say enable here. Are those perhaps C# compilation options, which maybe they allow? Start with nullable. Oh, they do. They do. So this is on the C# compilation options, and they allow to set them. Cool, cool, cool. So we need to. So we are sure. Are we sure that this is? Yeah, we are using C# source generator test. So we are sure that this is C#. So we can safely cast them to C# compilation options. And now with the C# compilation options, we can say with nullable annotations and set them here. Okay, but let's only set them if I don't want to impact any existing tests which are also using that. So I would like to make this I would like to find out what the default is. It should be disabled, but just to be sure. Compilation options, double context options. What are these? Let's debug this test. And per default should be disabled. Disabled. Excellent. Okay, which means let's create here another property where we can set the nullable context options, and per default they're disabled. And then we set them to what we defined up here. Okay, cool. And since in Roslyn everything is immutable, we must, after this with nullable context options, they do not modify this context options, but return a new instance of object context options. So we need to assign that. So we that return the new one. Well, we could shortcut that here. Oops. To return that here. Okay. So we now return this new instance, which has this nullable context options set. And now in our test, we could use that. We need here, do we need another? Yes, we do. Let's add another overload here. Let's call this nullable context options. Nullable context options. Make this optional, and we say if we have a value here, because that's an enum, so that's a value type. So that's a nullable value type. We check if it has a value, and if it does, we then set it to the value. Okay. And now we just need to invoke this in our test. Perhaps do I need to, let's add this to the overload that we are consuming. We're using 2 here. Let's jump to that. We're using that one. Let's pass them down. And we are using that overload. Let's pass them down here as well. Okay. Now we need reference assemblies. Have them here as well. The nullable context options. Make them null per default. Actually, let's require them here. For these tests, they must be set. They are quite crucial. So let's have them here. And also down there, the language version, let's make that one optional. And we pass that further down. Okay, and now we can use these. So, okay. Here we do have nullable annotations. So let's set them Nullable context. Let's enable them here and also here. But for this test, we disable them. And now we don't want to generate them. And let's see if this is now passing. It may be. We now, well, the unit test now sets up the compilation options correctly, which we would set via MS build, and the tests are green. So if we disable the nullable context, although we are using a net standard library which does not have this attribute defined yet, we do not generate the attribute. We only generate it if it's both enabled and also not available yet. If it isn't available, we don't generate it. Okay, let's actually, I will to move this here as well. For simplicity, I guess then I should parameterize those tests more to only have one verifier per test. But for now, I would like to give a bit of an overview and then refactor it later. But what about, yeah, what if we enable this here actually? So let's remove that from here. In this test, this is irrelevant. Or is it? No, it actually is. It actually, no, it isn't. This test, it's not. Hold on. This test, it totally is. In this test, it totally is, because if we do enable them via a source file, but we do not enable them in, it's actually the wrong enable. I meant disenable. Yeah. If we, so another test could be if we do disable it in the CS proj, but we do enable it in a file here, then we still want to generate it. So in that case, we also want to generate it. So, oops, I wanted to move that up. So in both cases, if we do use.NET Standard 2.0, where this attribute does not exist, irrelevant if it's enabled or disabled, because we enable the annotations here, we want to generate it. But if we use something, if we have it enabled and we have something where it is already existing, we don't want to generate it. But in the case where we don't have them enabled and we have them disabled here, although we using that standard 2.0 where it doesn't exist yet, we don't want to generate it. And let's see how these tests are going. I expect the second test to fail this one. And it does. Because we expected, what's the other test which fails? It's this test which fails. Okay. Okay, that's now bad because I have it in multiple. I have multiple asserts, so this is causing me trouble. Now I don't know which one is failing. Let's parameterize it. Let's make this a theory. And let's have the reference assemblies as a parameter. Let's call it ref assemblies. And let's have the nullable context options as parameter options. And now we need those. How is this working with NUnit? With XUnit? The source. Theory source. Oh, forget how to parameterize XUnit tests. Per unit tests. It's the inline class or member data. Yes, thank you, Andrew Locke. There yes. Okay, it's the member data where we say those are now the call it like the test data. And we define private static I enumerable of. There is also a strongly typed version of it. I think it's called test data. Is it not? There is also a post from Andrew Locke about XUnit strictly typed. Strongly typed. Test data, it's the theory data. Okay, not test data. Theory data, yes. Name. This will be a method which yield returns new theory data, where we set now these options. They are not const, so if we okay, duplicate that. So if we have a standard 2.0, either if it's enabled or disabled, we don't want to generate it. And that would be irrelevant of this annotation here. And let's consume them. Web assemblies and the options. Okay, but now I destroyed one test. What am I doing wrong? Oh, is there a .create method? No, not Nullable. Add. Oh, I have one theory data. Okay, okay. Hold on. It returns a theory data, not an enumerable of theory data. Okay. So that's a theory data of web assemblies and nullable context options that we return here. And then we have our data equals new theory data. Oops. Those types. Eventually we return that. Just add to it. Add. What? Add. So, okay. This could be collection initialized. So can just return it immediately. Okay. Now I guess we could turn this into an expression body. And this is not necessary. Yeah, I love it. Let's put this new here. No, that's fine. Let's think. Okay, cool. Okay, but we now destroyed one test, and the test where we actually let's move this one to a static here. Private, make it const. String. This is the generated code. This is the not null attribute. Let's move this here. Boom. And consume it there. Did it just remove it? Okay. Yes, but what if we have the same code. Okay, actually, this test is wrong. This should fail because it, if it's disabled, we don't generate it because we don't have the attribute here. Okay, I think I will split this up into just separate tests. The parameterization was a bit of an overkill here. Let's move it here. And let's back to effect. We have the not null attribute, and we add if not defined. The second test would be the not null attribute. Do not add if not required. In our case, if we disable the context. So we are in .NET Standard 2.0, but we have disabled the context. Yes, here we enable the context, so this is why we require it. But it should also not work if we have, for example, nullable enable annotations. It should still not work because we only enable the annotations, not the warnings. We only enable the warnings, we do not enable the annotations, and we disable it entirely, so this should not work. Perhaps we could also say here just the warnings. This should not generate it. However, now let's duplicate this test. So for this, we want to say add if context enabled. And the second test could be add if annotations enabled. So we could parameterize this actually. So let's make this a theory. Remember inline data. We pass in nullable context enabled, but also nullable context annotations, because in that case we also wanted nullable context options. We pass them down. Okay. But in the case that we disable them, and we are on .NET Standard 2.0, but actually still have the nullable enabled. So we have nullable enable annotations. It should still create it. Yes. But if we do not require it, so we have the warnings enabled on a context level or on a file level, only the warnings, not the annotations, then we don't need it. Okay. And is this test still relevant? No. Okay, so we put a bunch of tests. Okay, actually I made a mistake because in this case, I should not require it. So I remove the expected here. In that case, we only have the user code. But in the other cases, we do have the attribute as well, because we either require it via the nullable preprocessor directive or we require it via the options that we set. Okay, cool. This should be now predicting of when we want to edit. Let's see which tests are failing. It's only the first one. No, this one, add if annotations enabled. So we have them disabled here, but we do not inspect the source file. Okay, yes. We added this in the code, in the production code already, but we don't have this yet. And for that, this is a syntax node. We need to find out what node that is and can then have the syntax provider do that for us. So once again, SharpLab. Let's have a look how this looks like in what this looks like in Roslyn. We can change to syntax tree, and we see we have a compilation unit. We have a class directive, and where is this? This is a nullable directive trivia. Okay, I hope this exists as a type. Nullable directive trivia. Okay, now we go back to the generator, and we can now have our syntax provider. Syntax provider, context.syntaxprovider.create, and we have our that first is the syntactic check. That's the syntax provider predicate. This returns true or false. And the other one is the transform. Transform. Okay, let's put a new line. Let's create both methods. Let's make them both static. So we here get a syntax node and a cancellation token. And for the syntactic check, we would like to see if this node is a trivia. I already forgot the name. Nullable directive trivia. Nullable directive trivia syntax. It exists. Cool. And if this is a nullable directive, this doesn't suffice yet, but let's see where this goes. In that case, we could return true. Otherwise, we return false. And in here, we have a context and a cancellation token. We could assert here that the node of this is indeed syntax nullable directive syntax trivia, and let's just return that. We know that it is, so we can ignore the warning and oops, return that one here. Context.node, of course. Okay, which means we have here now a syntax provider. Now we need to combine that. Oops, this does not fulfill. The T is gone. Yes. Now we need to combine this syntax provider and this compilation provider. We can say var with compilation is the syntax provider collect, combine with syntax provider. Okay. And this is now a tuple, value tuple, where the first one is the collected syntax nodes and the other one is the compilation. So in our execute method, we need to change our source, which is here where is our execute method? There it is. So the compilation is now, actually, let's generate this and copy it from here. Replace that. So we have the right one is our compilation and the left node is our syntax nodes. Okay. Now we need to say here dot compilation. Okay. And add another check here. So if source if we haven't returned here yet. Okay, now we need, so if we have the type we can return, we actually need to make this now conditional. So if we don't have this flag, we return, but we also need to make sure to only return here if we don't have this flag and didn't find any syntax trivia node here. So if let's put this into a new line. If the nodes here, if the nodes here are null or empty, is default or empty. So if we didn't find any nodes, and if we do not have this flag set, then we return. Is this correct? Actually, I'm not entirely sure, but the test or deny. Is correct. If we have the flag, if we don't have the annotations, we don't need it. But if we do have annotations, or yeah, this actually should be, but the test still fails because the assertion here is the check here is imprecise because we only check, we do use any nullable directive. But in our test that fails. This one. We hold on. Should pass. Actually, what is this nullable directive trivia? Let's have a look. What's going on? I guess this check here is wrong. That's 6. So we didn't find any node. This didn't seem to be, this wasn't found. We are null or empty here. Okay. Did I write this correctly? Perhaps this is wrong. Sample file is correct. Seems correct. Nullable, enable notations. Yes, correct. Why is this not found as a, is it not? Let's have a look at this. Maybe it's not a nullable directive. Previous syntax. Maybe I'm doing something wrong here. Well, seems that I'm doing something wrong here. Okay, so what nodes do we get in? We get a entire compilation unit, we get in a using directive, we get in an identifier name, using directive, qualified name, identifier name, identifier name, class declaration, property declaration, fields, and so on and so forth. No, we really don't see that. So maybe this is, how do we retrieve that? Log once more. Is it perhaps a child node of this last using? Um, this is the entire compilation unit. This would be a using directive. What is it called? Oh, doch, child nodes. Perhaps this helps. So we run the test. I'm looking at the correct test. So I am. Using directive has one child. Identifier name. Now the identifier name with another using directive. Now it's a qualified name. Just that qualified name. This one has the qualified name and the identifier name. Qualified name, identifier name, and identifier. No. And then we immediately hit the class declaration. Okay. I'm not sure how to find out. Ah, yeah, it's telling me. It's telling me exactly because it's the trivia. Okay, the trivia is not a standalone node. It's part of the. How could we? How do we get that? It's part of the public keyword of this public keyword here. Okay. Hmm. Okay, so perhaps syntax. Well, we could ask every node because we don't know where this nullable enable is. It could be anywhere. It could be also like here. And if it is here, then it's again within the public. Okay, it's trivia of the next node. How do we get that? I'm not sure. Roslyn get nullable directive syntax trivia. Get preprocessor directives, perhaps. Do we know if a node is within? Does a node perhaps have nullable? Um, does the node knows if it's in a nullable context or something? No. Hmm. Means annotations. Token or trivia has annotations. I guess there is a nice way to find out, but I'm afraid I don't know that right away. I would need to do some research here or some more research. I guess we could check the Roslyn get nullable. Directive. Well, there's a way via the semantic model. I have déjà vu. I'm not sure if this is the most efficient way. It's probably not. But let's have a look at this. So I'm jumping to the other solution. I once built an analyzer which detects the nullable context of a node or for location. So we can ask that via the semantic model, we could check, we could get the nullable context of that. So we could pass in every node to the semantic model. This is not the most efficient thing, but let's try to go with that. Because we would check it for every node. Not sure if this is super efficient, but let's give that a try. Jumping back to the other solution. I did. And so in the syntax provider here, we would just turn true. Maybe there's something to find out whether this has trivia. Can we say like has trivia? Sure. Perhaps we can optimize the T a little bit. Do we know if there may be a relevant trivia in this node? This would be an optimization. And here, okay, this was wrong. Here we could now, the context as a semantic model, and we try to get nullable context of this node, okay? And we could say if, now this is again an enum. I believe this is now telling us whether it explicitly defines a nullable annotation or it is inherited by the CS proch basically. So we have, yeah, it's either disabled, warnings enabled, annotations enabled, both, or it could inherit the warnings from the CS proch, inherit the annotations from the CS proch, or inherit both from the CS proch. Okay, this is again a flags. So we could now ask if this node explicitly is defined in an annotations enabled scope. So basically if this nullable context has the flag, so actually this is wrong. We just have here, we don't know what node it is. It's just any syntax node. If it has a flag, but it's actually nullable because if it has the flag context dot annotations enabled, then we could return it. Return context dot node. Otherwise, null. This can be shortened. Okay. And now we need to filter. So in the syntax provider, we can now also say here dot where we get in a node. Where the node is not null. This can be static. Okay, and now we just have syntax nodes here. But we now have here we now have a nullable warning, I believe. Yes, nullability of reference types, because the syntax provider returns nullable syntax nodes. We do have a filter here, but C# doesn't know yet that this where now would remain with only the non-nullables. I guess we can just ignore that via a exclamation mark, can we? We can not. What we could. We have still syntax node question mark. Okay, I will deal with the nullable warnings later. Let's see if this is actually working. Let's try it. Success. Okay, cool. I thought this is the most efficient thing, but it works for now. We will definitely do benchmarking and profiling the next session. So this may be now a good follow-up on determining if this is efficient enough or not. And all the tests pass, which is super. Cool. I was wondering if we can optimize this here, but I'm not sure. If we can find out whether this node has some, I'm not sure what the node dot has leading trivia has a structured trivia, determines whether a descendant trivia of this node is structured. What's a syntax annotation? I have no idea. Syntax annotation is used to annotate syntax elements with additional information. Since syntax elements are immutable, it requires creating new instances. Are there some well-known syntax annotations? There's an elastic annotation. We define syntax annotation that indicates whether a syntax element has elastic trivia. Don't know what that is. Okay, I need to do some research on that. Perhaps we could find out whether if it has leading trivia or trailing trivia. Perhaps we could filter with that a little bit. But we would do the, okay, get leading trivia. Is this method expensive? I don't know. Not sure if this optimization actually would bring performance or harm performance. But yeah, for that we would need profiling. For now, I will use that. Not sure if this is correct, or actually does anything. But in a future session, we could then inspect if this is actually bringing us performance boost or if it's harming performance. Okay, so does this still run? Does this still pass? It does. Superb. Now looking back at the test, I believe this is actually quite complete. I'm not thinking if there is any other use case where we perhaps do not want to generate this attribute, or where we do want to create it. So we want to create it if we are in a nullable context, like on a project level. Then we create it. If we are not, then we still want to create it if we are on a if we have it anywhere enabled in our source file, which means we perhaps plan to now migrate to using nullable reference types, then we also want to create it. But if we only have the warnings enabled, if we have no annotations enabled, then we do not want to generate that. Okay. Now what's left is to do the same with all the other attributes. Because there is many. We now took care of one. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more to go. Not sure how to do this yet. I will do this off stream. Perhaps derive multiple generators from it, or maybe just have one generator, which then I guess one generator is fine. Not sure yet. And then basically add tests for all of these in the same manner that we just did. And then I believe there is for now one thing left to do. What I like to do is to depend on the language version. So if we need to support, let's have a look. Let's have a look at then basically at our integration test. Yes, we're not done with testing yet. We have added this test here. So we are in this example, and we are targeting both net6 and net472. The attribute is available in net6, but it's not available in net472. So now this allow null attribute should be generated for net 472, but not for net 6.0. Yes. Let's have a look. We do not have that set here. We could go to the this one. We can, this is in here. So we now basically tell the compiler to emit the compiler generated files also to disk, and to put it into the intermediate base output path. So let's build this. I have an error. It doesn't seem to work yet. But why? Why is this not failing? Is the entire generator crashing, or is tooling? Let's do a .NET build on the solution. Let's build. Hmm. Did it break the other generator? So, no, I didn't. But yeah, this is not generated because it's not required. I deleted the record class. No, public field um, record class record. We need something which actually requires this external uh, class, of course. So int number. Now the generator should kick in. Yes, okay, excellent. Now it works. And it builds. And yeah, so this test also, if I jump to this analyzer test, yeah, we have both. We do not have any NuGet package which includes the um, attribute, but it does build on both target frameworks. So if we go ahead and do a .NET test, it should now run for both net, where is it? Net 6.0 and net 472. So if it doesn't exist, it is generated. Let's now have a look at the output. We can go to obj, generated, nullable attribute, and here is our generated file. And that's the thing which is generated. So that works. But I would like to, I should also be able to, yeah. So if I hit F12 on it, we see that for the .NET Framework version 4.7.2, this attribute is actually defined in the assembly itself. So it's internally, that's the internal one which is generated. But on if for net 6, it's actually coming from the BCL. So if we jump there, we will go to the external sources. So this is actually the code from Microsoft. Yes, so this is somewhere from my local disk. And if I jump to the version of not 4.7.2, this is the one which is actually generated by the generator. We see here nullable.g.cs. Cool. So that works. And we could, anything else we could test here? Have a look at the mutation testing and code coverage in general. Let's, oops, testing. Let's do on the generator tests, let's do a cover the unit tests. And also some additional goals here. Also start mutation testing in the background. So we will be using .NET Striker, striker.net, .NET tool. Let's see if we have it. There it is, .NET Striker. Let's see if we have the most current version. .NET tool update, .NET Striker do. So we can say .NET Striker, boom. Okay, so this is now doing mutation testing. This will take a bit, and while it does that, we have a look at the code coverage report. So there is our nullable generator. We have 90%. So what are we missing? We have coverage here. We don't have coverage here. Okay, that surprises me. So we don't have this return here covered. We have no unit test which actually earlies out if this attribute is already defined. That's surprising. Because we do have a test for that, don't we? We do use somewhere. Oh no, I deleted that. I did delete it. Okay. I accidentally removed that test. So we need a test where we basically have it already. So let's copy this first one. We have add if context enabled. So let me cancel mutation testing. Yes. Oh, it's already completed. Oops, sorry, jumped to the wrong solution. So we have a test where we add if context is enabled. Add if annotations are enabled. Do not add if not required. And we need do not add if already existing. So we will set fact everything up that we definitely need it. So we're actually using it, but we remove it from it expected because what are my options? Nullable context options dot enable, and but we are using net core 3.0 since in here it's already existing, so we don't need to generate it. Let's see if the tests are still passing. They do. Now let's start that mutation testing again while we regenerate the code coverage. It should be now 100%. Still going. Okay. %. That's not what I expected. Did I selected the wrong one? Cover unit test. I perhaps selected the wrong option. Code analysis is external. Okay, yes, now we have better coverage, but still not 100%. I don't see the markers. Doing something wrong. What am I doing? Let's generators. Cover unit tests, please. Not sure what I'm doing wrong. But perhaps I'm actually lacking. Still some coverage. Selected all target frameworks. That's the one. I was looking at the wrong file. There it is. No, there it is. Yes. Okay, I was looking at the wrong file. Sorry. But we still only have 20. I am looking at the wrong. Still looking at the wrong file. There it is. Nullable attributes generator. So there it is. Yes. Okay. Got it. Now it's covered. Sorry for that. Okay. Now we have 100% coverage for the nullable attribute analyzer. I should fix those missing 3% from this other generator. I will do this later. Cool. Now let's have a look at the mutation test report. Let's open that up. Control click. Zoom in. So we have here the code analysis. Here is the nullable attribute generator, and one mutant has survived. We killed 15 from 16. We have no ignores. The one survived. Where do we have? Okay, this one. Mhm. This would be the optimization that we had. So we could basically, there is no test which confirms that this is required, because it just changed to something else, and it's still no test is failing. So yeah, but this was meant as an optimization. So let's actually remove that for now, because I don't know if it actually is an optimization, and we will tackle this in the next episode in a fortnight. I again jumped to the wrong solution, where we will have a look at how we can benchmark and profile source generators. And we will use this as an entry point. So let's jump to the nullable attributes generator, and for now just have turn true. This will be the to-do for let's code number 9, profiling and benchmarking. Okay. Now let's do one more test run. And basically, now what's left to do is to not duplicate, but generate. Perhaps there's a lot of to attributify tests for all the other attributes as well, so that they're only generated if they are needed, meaning that we actually do want to use nullable reference types, and also the type is not defined yet either by the user, because the user could edit manually, which would be another excellent test, wouldn't it? Let's add one more test. So if the user defines it themselves, let's copy this test. And let's say not null attribute, do not add if defined by user. So if we go back to net standard 2.0, so we are in an enabled context, we actually using it, we do require it, but we don't have it. So this test should initially fail. Yes, we expected. Why is it? So we enabled it actually. Yes, so it is generated. It is generated. We expected only one file, the user file, but we have two files, which includes the generated file. But the test is not complete because we want to have it defined by the user. So I go one last time to the source code and copy this attribute. Oops. And now let's have it defined by the user. So we added the user code here. We're in the namespace code analysis. Do we have the system using? Yes, we do. So have attribute usage. Let's user define it also as internal in our case, and we define the attribute ourselves. We need to close the brace, and now this test should pass because the user is defining it. It's already there. It's not coming from the BCL, but it's coming from the user. So we still do not need to generate it, and the test passes. Very cool. And now one last thing, because I love overkill. Currently, the attribute that we generate is C# 10 style. We are using nullable reference types. we are using file scope namespaces. If we would go to our test here, and if we would, not this test, I meant this integration test here, yes. And if we would set the language version to 8.0, because in C# 8.0, nullable reference types have been added, and where this nullable context and everything exists in the first place. So this should be the minimum version that we support. But if I try to build now, we will get build error. And somewhere must be an error in our generated file. Okay, first of all, global usings are unsupported. Let's get rid of these. Let's actually clear everything up. To add this manually, no more global usings. Yes, and we need to convert this into a file scope namespaces. Is there refactoring for that? No. Let's convert it manually. Okay. Yeah, we don't have the init keyword here. I will ignore this for now. And we jump over here, convert this to file scope namespaces, to block scope namespaces, sorry, as well. Okay. And if we build, then now we only have errors in our generated file. No, that's still global usings. We still have global usings somewhere. Yeah. Global usings are quite empty. Why? Well, we can just remove this file. So I still have it enabled in the. Do I have a? Let's disable it. Implicit usings disable. I now need to use the system. Okay, all the implicit usings are gone now as well because they don't exist in C# 8 yet. Okay, now I should remain with this one error that we expect, and it is now in the, oops, we have it here. Feature file scope namespace is not available. And this, I believe, is coming from the, let's remove this test for now. Don't care about this external init for now. And this error is now coming from this generated file. So if we jump to here, go to our generated file, yeah. But the user has no control. The user cannot fix that. I can't fix that because it's generated. So we also need to support that. We need a test. This will be the last test for this session, most likely, where we are going to also assert lower language versions. Oops, that's the wrong. There they are. Nullable reference types. Which one is good to copy? This one also work for C# 8. So not null attribute, add if context is enabled. C# 8 0. We don't need these because we only say this will be the nullable context options enabled. We definitely need it, but we on C# 8. This will be a fact. And what we generate here is now a little bit different because this will be the nullable attribute C# 8 version, which is not using file scope namespaces. Yeah. Is this now valid C#8? This is valid C#8. And we go down to the test. And instead of the nullable attribute, we set the nullable C#8 attribute. And we also need to set the language version. So we can pass in here the language version to C#8. Let's see how this test is doing. It is failing. Because, yeah, here we see the minuses and the pluses, they are around this file scope namespace or block scope namespace difference. Okay, so our generator will need one more thing. We are going to need the parse options where we can read the C# language version from. So we need one more with parse options where we are going to combine what we combined previously, the with compilation, we will combine with. The context has a parse options provider. Okay. And we will pass in the parse options here, which means that, hope I will do this correctly now. The left one is splitting up. Okay. So that means that this is now a tuple within a tuple. I will call this other. And the other one is the parse options. Let's call them parse options. This should fulfill the contract. Okay, it does. And we now need to say here dot other. Okay, and if we want to generate it, we need now to extract the C# parse options. Do I have an extension for this already? Perhaps I do. I do have parse options extensions. Try get C# language version. That looks promising, where we can just use that. If so, we can from the source we can use the parse options dot try get C# language version. Import the using, and this will be an out language version version. Am I doing something wrong? Oh, it's not nullable. Yes. Okay, and if we do this fails because it isn't C#, we can return. But if we do, we can now see if, let's say, a Boolean, if we have as file scoped name spaces. If we have that feature, this is true if the language version is C# 10, at least if it is C# 10 or higher. So greater than or equal to C# 10. And if we do, okay, now we need some conditionals. So let's do a indented text writer. Indented text writer. And what does this one get? This gets a text writer. String writer, perhaps. Writer equals new. And I believe this is possible without an explicit. I think implicitly it creates internally a string builder. If I remember correctly. I believe so. Yeah, it could also receive an explicit string builder. And we're gonna pass that writer here. I believe both of them are disposable. And we're gonna use that indented text writer to write a line. So we can say write line. We first write the auto-generated line. Then we write the nullable, enable line. then now it depends on the namespace already. So if we have file scope namespaces, we are writing headline. But if we don't, we would like to write a log scope namespace, which means in the next line, we are going to need I think I have a static for that. I think it's in tokens dot open brace. Yes. And since we're opening a brace, we also want to increase the indentation. So we say indent plus plus because we now opened a new block. Then we go on in writing attribute. So we say text.write line, writing the attribute usage attribute for this attribute text.write line, like so. Okay. And at the end, if oops, I deleted. Yes, we're not going to need this anymore. And at the end, if we are not using file scope namespaces, if we don't have them, we need to close the previously opened block. So we go textWriter.writeLine. No, actually, first we need to outdent. So we say text.indent minus minus. And we now need to token.close close brace, which is basically just the close brace character. And this should be it. So at the end, we could assert debug.assert that indeed the indent level is back to 0, where we started, so that every opening, every indentation also has an outdentation. Is this English? If every indent also has an outdent. And then we're gonna pass the string writer dot to string to the generation. And let's run the tests and see how they are doing. Uh-oh. Oh, yes. Okay. I failed to add 2 new empty lines here. So let's jump back to the generator. Before we want a empty line here. And also an empty line here if we use the file scope namespaces. Let's run the unit test again. One is failing. Okay, there we see it. We expect tabs but have spaces. I personally prefer tabs over spaces. So is that wrong in the test, or is this wrong in the, I believe it's wrong in the test. No, it's not. Then it's wrong in the, yes, in the indented text writer, because the indented text writer per default uses the default tab string for spaces. But we would like to use tabs. Do I have I believe I also have a constant for that already. I think it's in trivia.tab. Yes, there it is. I think it's just a /tab. Yeah. And this should render the test white green. And it's 00FF00. Indeed. Oh no, but not on. Okay, so running the test in .NET Framework passes, but running it in .NET Core fails. That's We still have the spacing issue on .NET if it's executed on .NET Core, but not in .NET Framework. Is weird. I never observed this before. Hmm. Is there something? No, this exists in .NET Standard. .NET Framework exists everywhere. I can't explain my... Hmm. Do we still have the spaces issue here? Okay, now it passed. I'm not sure. Was it still you? I don't know. Let's run them all again. Okay, it's green. Cool. Yeah, so now if we go back to the integration test, there it is. This should now work as well for both frameworks. So if I build everything, now it is. If we have a look at the generated version, it now uses the file block scoped. The block scope namespace if the language version is not C#10. But if we jump, let's higher the version to 9. Let's build it. Jump to the generated attribute, still using block scope namespaces. But if we now set it to language version C#10, build it one last time, jump to the generated version. Now we see we use file scope namespaces. Okay, cool. So we don't need to care about lower language versions than C#8 because nullable reference types exists in C#8 and higher, so it doesn't really make sense to worry about that. So I would like to do one last, again, because we changed a bit of source code, run the mutation test again, which now should kill all the mutants, and also do another test coverage report. Cover selected unit tests. Uh-oh. Is it because I'm running both? Uh-oh. Something is wrong, very wrong. Perhaps I should do it not simultaneously. If I now cover the tests, and then one striker. Okay, we do not have 100%. We have... I'm again looking at the wrong generator. How often is this going to happen? There it is. Okay, so this is not covered. We do not have any test where we do not find the language version because this try get C# language version basically checks if the pass options are actually, the language of these pass options is indeed C#, so that we can then safely cast it to C# pass options and then return the language version. Otherwise, we return the default. But since we have attributed this generator with that it applies to C sharp, I believe the safety net here is not required. So we could basically just discard that boolean that we retrieve from here. So let's do it like this, and we just continue because we assume we are on C sharp, so this should work. Perhaps we should have a version of this which doesn't try it, but actually just does it because it assumes it's right. So let's call this get C sharp language version, where we just return the language version. And let's do a debug.assert here that we expect this to be C sharp, otherwise something is wrong. But we basically just keep this code. We cast them as C sharp pass options. We expect them to be not null, and then we return the language version from here. And let's use that one. And then we get the language version directly. Okay. So let's and we have a nullable warning here. Okay, I still haven't figured that out because this is not actually syntax nodes of question mark, although we do filter them, but compiler doesn't know it. Can we? We can't just slap a oh yes we can. Yes we can. So we just suppress the nullable warning here because yeah, we filter all of them which are not null, so we can safely say these are not null. Okay, now the warning should also be gone. There are no problems. Use some explicit type here. Okay, let's do that. Those are the nodes. This is the compilation. One more explicit type to be used, nodes compilation. I call this other, and this the parse options. Okay, no more problems left. And it's time to cover one last time. But this time I'm looking at the correct file. I hope. When this is completed, I will immediately start the mutation test again. Okay, so this time selecting the correct file. It is the nullable attribute generator, and we do have 100%. Control 1, there it is, which is cool. And let's see. Okay, this striker will now take a bit. Until striker has completed, let's jump to the agenda. Every link that we explored during this session, I will put into the resources later on, probably tomorrow. Let's see if we have completed our plan. We had a look at the init only setters features and how it requires the isExternal init type to be existing. If it's not existing because we're using something which is not compatible to .NET 5, where this type has been added initially, we could either provide it manually, we could provide it via the NuGet package from Manuel Römer, or we could have a generator generating them if they are needed. Then we had a look at the nullable reference types in general and at some of the nullable reference attributes, and then had a closer look at the allow null attribute, and we could the same way provide it manually or also use equivalent package also for manual Römer, which provides those attributes if they're not existing in the current target framework. And then we implemented test-driven style and incremental generator, which provides one of them, so only the null attribute, the allow null attribute if it's not existing. I will do the others off stream. We always have a look at the code coverage, and we always have a look at the mutation testing report. Speaking of which, it has completed. Let's check out the report. There it is. Let's jump to the nullable attribute generator, and we have a score of 100%. We had 45 mutants killed, uh, um, 43 of them. 2 were ignored. Let's have a look at the ones which are ignored. I believe, because I usually ignore debug asserts. So here are 2 mutants which has been ignored. For example, removing the method entirely, and also changing this assertion in the debug assert. But since it's just a debug assert, I always exclude them. So that's fine. And all the other ones have been killed. Just a brief look at, yeah. Since we have now much more code, we had an indented string writer. There's a lot of code. Also this a condition here. So if we change this to a just greater than and not a greater than or equal to, then we fail already. And the mutant is killed, which is very cool. So 100% is excellent. And we had a look at the mutation test report. Cool. I will add the resources, all the links that we had a look at tomorrow. Already teased the next stream, so it will be in 2 weeks again, same time, just before the week where the NDC London is taking place, where I also talk about source generators. I'm very looking forward to that. And in this session, then we're gonna have a look at benchmarking and profiling and how to do this with source generators and incremental generators. And we already have a bit of an example that we could segue into in this next session in 2 weeks. So yeah, that's it. I want to thank you very much for staying a while and listening, and may Roslyn be with you all. Goodbye. I'm searching the outro thing. Where is it? Stop. I used the wrong command name.